Welcome to a slow, beginner-friendly lesson on what types are, made for absolute beginners. This lesson is an overview of types. We will not master every type today. Each major type gets its own slow videos after this. Every value in Python belongs to a kind. The number 42 is a whole number. The word hello is text. The value true is a yes or no. These are not random labels. They are categories, and each category behaves in its own predictable way. Just like in everyday life, where an apple and a bicycle are different categories of thing, and you would never try to ride an apple. Python sorts its values into categories too, and the category a value belongs to is called its type. Every value has a kind. A category is more than a label. It tells you what makes sense. You can count how many apples you have. You can ride a bicycle to the shops. But you cannot ride an apple, and counting bicycles makes no sense as a snack. The category tells you which actions fit. Python works the same way. The type of a value tells you which operations make sense for it. Adding two whole numbers makes sense. Adding a number to a line of text is a question mark. The type decides. The category decides what fits. Picture a zoo. Each enclosure holds a different kind of animal, and each one needs the right care. Python values are like that too. They live in categories, and each category has its own rules. A whole number is not the same creature as a line of text, even though both are good values. A small, orderly zoo. So in Python, the word type just means category. Every value has exactly one type. The type says two things at once. First, what kind of value this is. Second, what you can do with it. When you know the type of a value, you know which operations will work and which will fail. That is the whole idea. A type is the category stamped onto a value, telling Python how to treat it and telling you what to expect. The whole idea in one line. Let us meet the main cast, the types you will use almost every day. Int, written int, holds whole numbers like 3 or -7. str, written str, holds text, anything wrapped in quotes. Float holds numbers with a fractional part, like 3.14. Bool, written bool, holds only true or false. And there is a special value called none, which means nothing is here. We will look at each one gently over the next few minutes. For now, just hear the names and let them settle. Hear the names first. Our first type is int, short for integer. An int is a whole number, with no fractional part. Age, count, temperature in degrees, these are all naturally whole numbers. You write them as digits, optionally with a leading minus sign, and no decimal point. 34 is an int. -5 is an int. Python stores them exactly, with no rounding, because they are whole and clean. Ints are the type you reach for whenever you are counting something. Whole and clean. Our second type is str, short for string. A str is text, a run of characters wrapped in quotes. A name, a sentence, a single letter, even an empty pair of quotes with nothing inside, all of these are strings. The quotes are how Python knows, this is text, treat it as text. Ada in quotes is a string. Ada without quotes would be treated as a name, which is a completely different thing. The quotes make all the difference. Quotes make the string. Think of types as families. Every value is a member of exactly one family, and the family decides what the value can do. A whole number belongs to the int family. A piece of text belongs to the str family. Knowing the family is knowing the value's nature. It is the first thing to learn about any value you meet. One family each. Our third type is float, short for floating point. A float is a number that can have a fractional part, written with a decimal point. Prices, measurements, anything where the fractional part matters, these are floats. 19.95 is a float. 3.14159 is a float. The decimal point is the signal. If you see a dot in a number, Python treats it as a float, not an int, even if the fraction is 0. The dot is the signal. Our fourth type is bool, short for boolean, named after a mathematician named George Boole. A bool can hold only one of two values, true or false. That is it. Is the user logged in, yes or no? Are there errors, yes or no? These yes or no questions are the heart of every condition in programming, every if statement. Bools are small and simple, but they run the show. Notice that true and false are capitalized. That matters. Yes or no, that is all. There is one more special value to meet now, called none. None means, there is nothing here. Not 0, because 0 is a number. Not an empty string, because that is text. None means the absence of a value. You will see it often when a variable has been created but not yet given anything meaningful to hold. Think of an empty shelf. It exists, it is ready, but it has nothing on it yet. That state is none. Nothing, but on purpose. Every value you will ever write belongs to one of these families. Whole numbers, text, fractional numbers, true and false, or nothing at all. 5 simple categories, and almost all of Python fits inside them. Once you can name the family of any value, you are already thinking like a programmer. 5 families, almost everything. So why do types matter so much? Because they tell you what fits. Adding 2 whole numbers makes obvious sense, you get another whole number. But adding a number to a line of text is confusing. Does Python add them, join them, or complain? The type is what decides. When the types do not match the operation, Python raises an error and stops, which is actually a kindness. It is far better to stop and tell you than to quietly produce nonsense. Types are Python's way of keeping your work honest. Honest work, stopped kindly. Here is types doing their job. We add 3 and 4, both ints, and Python gives us back 7, also an int. Same with 10 plus minus 5, we get 5. When the types fit the operation, everything just works, and the result is the type you would expect. This is the calm case. 2 values of the same type, an operation that suits them, a clean result. Most of programming looks like this. The calm, working case. Now the interesting case. We try to add the string hello to the number 5. Python refuses. It raises a type error and tells us, in its own words, that you can only combine a string with another string, not with a number. This is not Python being difficult. This is Python protecting you from a meaningless result. The type mismatch is the warning bell. It says, these 2 values are different kinds of thing, so this operation does not make sense. The warning bell. That error might look scary the first time, but it is actually a friend. A type error stops a meaningless operation before it can produce a wrong answer. It points at the exact line and tells you the types do not match. That is a huge help, not a punishment. Beginners fear errors. Experienced programmers read them like signposts. When you see the word type in an error, the first question to ask yourself is, what type did each value have, and did they fit together? Read errors like signposts. A type is like a container shape. You can pour water into a jug, and you can stack books on a shelf, but you cannot pour water onto a shelf and expect it to stay. The shape decides what fits. In Python, the type is that shape. It decides which values mix well and which ones were never meant to meet. The shape decides what fits. Here is a picture to hold on to. Think of all the values in Python as a small zoo. Each enclosure holds one kind of animal, and only that kind. The int enclosure holds whole numbers. The str enclosure holds text. The float enclosure holds fractional numbers. The bool enclosure holds true and false. When you reach for a value, you are reaching into a specific enclosure, and the kind of animal inside tells you how to handle it. A type is just the enclosure a value lives in. A type is an enclosure. Every type comes with its own set of allowed operations. Ints can be added, subtracted, multiplied, and compared. Strings can be joined together, sliced into pieces, and searched. Bools can be combined with the words and an or. These rules are not arbitrary. They grow out of what each kind of value naturally means. You do not memorize them all at once. You learn them one type at a time, by using them. And every new type you meet later will bring its own operations with it. Rules grow from meaning. Here is a surprise that delights beginners. You cannot add a string and a number, but you can multiply a string by a number. Ha times 3 becomes ha ha ha. Python repeats the string 3 times. Yet subtracting is not allowed. Why? Because repeating text makes a kind of sense, but what would it mean to subtract 3 from ha? Nothing sensible. So Python allows it for multiply and refuses it for subtract. The type, and the operation together, decide what is allowed. Multiply works, subtract does not. There is a tool coming that lets you ask Python directly, what type is this value? It is a built-in function, and it answers in one word. That tool is the whole subject of our next lesson, so I will not spoil it here. For now, just hold the idea. When a value confuses you, when an operation surprises you, the first question to ask is, what type is this? Almost every beginner mystery in Python unravels the moment you know the type. One question clears the fog. Let us gather the whole lesson. A type is a category for a value. It says what kind of thing the value is, and what you can do with it. The main cast is small, int for whole numbers, str for text, float for fractional numbers, bool for true and false, and none for nothing at all. Each type brings its own allowed operations, and when types do not fit an operation, Python raises a friendly error to stop the nonsense. Hold those ideas, and the word type already feels ordinary. Types give programmers a shared language. When 2 developers talk about a value, they ask, what type is it, And that single question clears up most of the confusion before it starts. Learn the names of the types, and you can already talk about your code with anyone, anywhere. A shared language. The takeaway, in one breath. A type is the category a value belongs to. It tells you what kind of value you have and what you can do with it. When the operation fits the type, Python runs happily. When it does not, Python stops with a friendly error. In the next lesson, we learn the simple tool that lets you ask any value, "What type are you?" That one question will save you from more confusion than anything else you learn this week. Take a breath. Another brick done. Another brick placed. Thanks for watching. Next, checking and saying types.